In this video, we're going to simplify rational expressions. So let's first take a look at what a rational expression is. That's going to be an expression where we have some sort of polynomial. Notice that we have a polynomial in the numerator, and we have a polynomial in the denominator. So that's what's considered to be a rational expression. And so what we want to do is learn how to simplify those. When we simplify a rational expression, what we're going to do is, just like with a fraction, we're going to get all the factors out of the numerator and denominator, all common factors except for anything that's a plus or minus 1. And to do that, we're going to actually have to break the numerator and the denominator down into its simplest factors, and then we'll cancel, which is the same thing as dividing out any common factors. And what we may have to do sometimes is, if the original expression has a variable in the denominator that would cause that denominator to go to 0 for certain values of the variable, we're going to have to specify those, because the simplified expression may actually divide out those variables, and we wouldn't be able to have any view as to what would have caused the original expression to go to 0 in the denominator. So we'll have to make a domain specification. So let's look at a couple examples. In the first example here, we see we just have a normal fraction. It has some numbers, and let's go ahead and simplify that. So I could say that 15, that's 3 times 5, and 65, that would be 5 times 15. 5 times 13. So what we can see is that the 5's are common to both the numerator and the denominator, and we would get 3 over 13 as the simplified answer. Now we have a little more complicated problem, and what we need to do is we need to factor this. So for the numerator, we're looking for two numbers that add to a negative 4 and multiply to a negative 12. So we could use x minus 6 and x plus 2. That would be the factors for the numerator. And the denominator is a difference of squares, so we would have x minus 2, x plus 2. Now then, so all we've done is factor this, and let's go ahead and cancel out any common factors. So we could see that actually what we have is we have the factors x plus 2 in the numerator, x plus 2 in the denominator. So my final answer would be, after I remove those common factors, would be x minus 6 all over x minus 2. Now, what we notice, though, is the original expression, we have x minus 2 and x plus 2 in the denominator. And notice that x plus 2 is no longer in the denominator. So we've lost visibility that actually, if I had a value of x in the denominator of a negative 2, this particular factor would go to 0. So we have to specify what values in the original expression would create this would create zeros. So we would say that x cannot equal to 2 and x cannot equal to a negative 2. Next problem. This one is already factored, so I don't have any factoring to do. So if I cross out the common factors here, and let me go ahead and rewrite it. That the common factors would be this x plus 1 and this x plus 1, leaving me with 2 all over x plus 3. Now I need to specify what would have caused the original expression to go to 0 in the denominator. So I couldn't have an x value equal to a negative 1. And I can't have an x value equal to a negative 3. Let's move on to the next one. Let's factor this. So what we'll have is x plus 4 over x minus 4, x plus 4. Let's go ahead and specify what would cause the denominator to be 0. That would be x equal to 4, so I can't have that. And I can't have x equal to minus 4. And we can see that once I factored it, these x plus 4s will cancel out, and what I would be left with in simplified form would be x minus 4. Okay, the next one, what we have is 4 over x times x plus 2. That's already factored, and there are no common factors, so this is as simple as it's going to get. And we need to go ahead and specify what values I can't have in the denominator. So I can't have x equal to 0. That would cause this x to go to 0, or the denominator becomes 0. And in my second factor, an x value of a negative 2 would not work. Next problem. Let's factor this. So I'm looking for, in the numerator, two numbers that multiply to a negative 3, add to a negative 2. So that would be x minus 3 and x plus 1. In the denominator, I'm looking for two numbers that add to a negative 1 and multiply to a negative 6. That would be x minus 3 and x plus 2. So we can see that in this expression, if I had an x value equal to 3, that would make the denominator go to 0. And an x value of negative 2 would also make the denominator go to 0, so I can't have those. And what I would have is these x minus 3's would cancel, leaving me with x plus 1 all over x plus 2. And that's how we simplify rational expressions.